afternoon, everyone. Am I audible? Hello, am I audible, students? Okay. Okay, so less students today. Why 14 students only? All your friends, or are they having exam? Okay, we shall start. Can anybody tell me what did we do in the last class? If you remember, did we complete the treatment chapter? Or we were in the middle of the distribution system? Can anyone remember? As far I remember, I think we were in the middle of the distribution system part. Am I right? We were discussing about the requirements of a good distribution system. So that day I couldn't provide you the PDF. I couldn't show you the PDF, but today I have brought the PDF. So we were discussing about your distribution system. Okay, so what I told is that after the water, it has been properly treated, and it has been made it is made completely safe now, and it is ready to to be supplied to the consumer. So how to supply it from the treatment plant, how to carry the water from the treatment plant to the consumers. Okay, it is through a distribution system. Okay, so what a distribution system consists of? So a distribution system, it consists of many things. Okay, like it consists of pipelines. Obviously pipelines everyone knows. It's of different sizes. Okay, for carrying the water to the consumers. Then it also consists of valves, and valves are required for what? For controlling the discharge. Okay, then again, we have hydrants. Hydrants are for what? For providing the connections of the recharges. Okay, and also the individual service connections. Okay, so all these things, and again, pumps. We have pumps are also used for lifting the water, or no, forcing the water to the distribution pipes. Okay, and then we have your distribution or service reservoirs. Okay, for storing the treated water. Okay, so all these things are consist in a distribution as a whole, which is known as your distribution system. Okay, so again, we have discussed about the requirements of a good distribution system, like what are how a distribution system can be called a good distribution system if it fulfills your certain criteria. Okay, so what are those criteria? Like it should be capable of supplying the water at all places. Okay, so within what within a low pressure head. Okay, and then again it should be now during emergency purposes when fire breaks out, then you should be able to capable to supply the water. Okay, requisite amount of water you have to need to supply. Then again it should be in the distribution system, it should be cheap, with the least construction cost. Okay, then again for repairing purpose and all, it should be easy and simple to operate. So all these things, and also it should be it should be safe against any future pollution. Okay, so all these things, if it fulfills all these criteria, then you can say that it is a good distribution system. Okay, So you can write down all these things in your copy from this PDF. I will provide it to you. Okay. So now we need to talk about the layouts of a distribution system. So what are the layouts basically? Okay, just give me a minute. I need to charge my laptop. Just wait. Okay. So there are, below the grounds, below the roads or streets, everyone, we have seen that the municipal people, they are digging up the roads, okay, and they are laying the pipes, okay. So there are certain layouts. You cannot just put the pipe in any way you want. Okay, there are certain layouts. Okay, so layouts like how to put the pipes, in what order we need to put the pipes. There are certain layouts. So what are those layouts? Number one is your dead end system. Okay, number two is your grid iron system, number three is your ring system, and number four is your radial system. So first of all, let us discuss about the dead end system. Okay, so the dead end system, it is also known as your tree system. Because why? Because the structure or the layout, it looks like that of a branch of a tree. Okay, and dead end system, it is it is adopted in older towns and cities. Okay, in old towns and cities which are already being developed, and they are developed in a haphazard manner. Okay, there is no that means there are no planned roads or streets. Okay, they are already been developed, and they are older towns. Okay, so for those type of towns and cities, your dead end system was adopted. Okay, and what happens in dead end system, there is only one main supply pipe. Okay, there is only one main supply pipe, and from that supply pipe, your the different types of different numbers of sub main pipes are originated. Okay, and from that, again from that sub main pipe, what happens, your different branch pipes are originated. Okay, which are also called laterals. Okay, the branch pipes are also called laterals. So like that, it goes on increasing. So that looks like a kind of tree. Okay, so let me show you the diagram. This is the diagram you see of a dead end system. So here basically you can see that this is a main supply pipe. Okay, this is a main supply pipe. Then from the main supply pipe, these are your sub mains. Okay, these are your sub mains. The in the designation you can see it is S written. Okay, it is S written. So those are supply pipes. Sorry, sub main pipes. Okay, these are sub main pipes, and it is not like that that it need to be. It can be 90-degree. Okay, and also it can be 45-degree. Okay, so these are your sub main pipes, and again from the sub main pipes you can see that your branch pipes or laterals are being originated. Okay, so you can see that from the sub-main pipes you can see the laterals, okay, or branches. Okay, and the end of the branches are being closed. Okay, like this, they are being closed. Clear? So, and what are these? And these are this dot you can see. This dot you can see, these are your cutoff valves or gate valves. Okay, those are needed to open the pipe or close the pipe. By that you can increase or decrease the discharge. Okay, according to your needs. So this is the diagram about your dead end system, and it is a kind of similar. It looks like a that of a tree. Okay, so uh, there are there are certain advantages and disadvantages of each of the layouts. So what are the advantages of dead end system? Let us see. Number one is the distribution network can be solved easily, and it is possible to easily and accurately calculate the charges and pressures at different points in the system. Okay, so obviously the network, the layout, it is a very easy one, and it can be solved easily also. Okay, and you can find the charges more easily and more accurately. Okay, and the pressures, it can also be find at different points in the system. So next point is, what is the advantages is that lesser number of cutoff valves and are required in this system. Okay, yes, from the diagram itself you can see that only a few number of cutoff valves are present, like this one, one, two, three, four. Like these are very less numbers. Okay, so less number of cutoff valves are needed in the dead end system. So that is an advantage, and also shorter number of pipes are needed. Okay, here shorter number of pipes are needed since there are submains and laterals. So longer pipes are not needed here, and it is also cheap and simple, and it can be extended and expanded easily. Okay, so these are the advantages. So now let us see what are the disadvantages. Okay, so disadvantages is one. Number one disadvantage is what? Since it has a one main supply pipe. Okay, since you can see this is the one supply pipe. Okay, and from this supply pipe everything is being originated. Okay, from here only the water is going from the main supply pipe. So suppose any one part of the supply pipe, suppose here this pipe, it's been defective. Okay, or something happened to this part of the pipe. So what will ultimately be happen is that the person staying here, okay, the person staying here, or the person staying here, okay, or the person staying here in this part, what will happen? They will be devoid of the water supply, isn't it? Because the water is coming through only one main supply pipe. Okay, this is the main one. Okay, so if any part of the main supply pipe is defective, so what will happen? Or repair is going on. So what will happen? The persons staying in the other part of the places, they will also be affected. Okay, they will also not get water. Okay, so that is the main disadvantage of your dead end system. Okay, and the next one, what is the next one is that, suppose since here we can see that there are numerous dead ends. Okay, these are known as dead ends. So since these are closed, okay, since these are closed, so what will happen? The water coming like this, and it is the water that is going here in this way, it will be it no, it will remain. Okay, this will get blocked here. The water, it will be devoid of free circulation. Okay, it will not get free circulation, and some amount of water, it will be stagnate here. Okay, so what will happen in that case? The water, it might get polluted, or the water, it will become dirty after a few periods of days. Okay, so that is a disadvantage, that the water, it will be not getting free circulation of water. Okay, so number three is that since number third disadvantage is that, since there is only one supply pipe, one main supply pipe. So during emergency or during fire breakout, so what happens that people, you cannot increase the discharge. Okay, you cannot increase the discharge. Suppose there is a very big fire breakout in this place, so you have to depend upon this main supply pipe, or you cannot get water through any other network. Okay, there is no any other way to get the water. You have to depend upon this main supply pipe. Okay, so if the discharge is low here, then you will get the water at a low discharge. Okay, there is no other way that you can increase the discharge in this area. Okay, so that is a great disadvantage. So these three are the disadvantage of your dead end system. Clear? So here the 3 points are there. You can write it down in your copy. Okay. So number two is your grid iron system. So grid iron system, it is also known as your interlaced system, or also it is known as your reticulation system. So here actually the main supply pipe, the branches or the submain pipe, they are all interconnected to each other. Okay, from the diagram only you can see that it is in a grid, it's a rectangular pattern or in a square pattern you can say. So here this is the main supply pipe, okay, and these are the sub mains you can see, and these are the branches, okay. So they are all interconnected with each other, and this type of system, it is generally used in a planned city. Okay, it is generally used in a planned city or developed city, okay, where the roads are well planned. Okay, so here also there are certain advantages and disadvantages. So let us see what are the advantages and disadvantages. So the advantages are like the since the water reaches at different places through more than one route, the discharge to be carried by each pipe, the friction loss and the size of the pipe therefore gets reduced. Okay, since obviously since here the water, it is being supplied through more than one route. Okay, there are many routes. So obviously the discharge carried by each of the pipes, it will get reduced, isn't it? The friction, the loss of friction will also be less, and also the size of the pipes will also be reduced. So and also in case of your repairs, if any part of the pipe it is being repaired, so the other people, they will not be they will not be devoid of water supply, since they are getting the water through many routes. So if any one route is affected, or if any one route is affected, so they will be getting water from the other routes. Okay, so that is one advantage. And another advantage is that, you know because there are different interconnections, okay, so there are so many interconnections. So what happens, the water, it is in continuous circulation, okay, and the since it is in complete continuous circulation, so there are no dead ends, and so it is in continuous circulation. And so what happens, the water, it is not liable to pollution, or due to what, due to stagnation of water. Okay, so that is one number three advantage. And number four advantage is that since here everything is interconnected, so if any one of portion of the pipe gets, sorry, if any one portion of the area it gets fire, okay, suppose fire catches or emergency happens, so since they are getting the water from different routes, so obviously the discharge, it will be more, okay, and you can get water from different areas. So it is a advantage. Okay, so next is your disadvantage. So here what happens actually, the this system, it requires more length of pipes. Okay, it requires a more length of pipes, and also the cutoff valves or the switch valves through which the discharge can be manipulated. So that also, it is also in a large number. Okay, and here the grid iron system, its construction cost is also very high, and the design it is also a bit difficult, and also it is costly. Okay, the calculations are tough. So these are the disadvantages. Okay, so number three is your ring system. So ring system, here you can see it is a kind of a circular, or it is also sometimes known as your circular system, or a closed ring. Okay, you suppose why I am telling you here, you see here. So this is your main pipe, okay, then it is going like this, okay, and again it is coming like this, the main supply pipe, okay, then again it is going like this, okay. Oh, sorry, here also it is going like this, the water, then again it is coming like this, and again it is going like this. So this outer line is your main supply pipe, okay. this is your main supply pipe, and these are your submains. Okay, here as written, these are your submains, and these are also your submains. So here basically branches are not there. Okay, everything is submains and your main supply pipe. Okay, so that is your ring system. And here since the layout is of a similar kind of your grid iron system, so here the advantages and disadvantages of your ring system is a similar that of your grid iron system. Here, so number four is your radial system. Okay, so here what happens? Let me show you the diagram. This is your radial system. So here the distribution reservoirs, they are kept in a at the midpoint of your these are you can see these are the blocks. Okay, this is one block, two block, three block, four block. So here your distribution systems or reservoirs are placed at the center. Okay, then from that distribution reservoir or service reservoir, the water it is carried radially to the consumers. So here basically the town or city it is constructed in a radial system. Here you can see if a city or town is having a system of radial roads emerging from different centers, the pipelines can be best laid in a radial method by placing the distribution reservoirs at the centers. Okay, so from the centers, the water is being carried out to the radially to the consumers. Okay, so here also the advantages and disadvantages are the same as that of your grid iron system. Here, so these four are your the different layouts of your distribution system. So next, let us see what are the methods of distribution. Okay, there are certain methods by which the water can be distributed to the consumers. Okay, so number one is your by gravitational system, number two is your by pumping system, and number three is your by combined gravity and pumping system. Okay, so in a gravitation system, what is happening? Let us see by a diagram. Okay, so this is your gravitational distribution system. Okay, so here basically what happens, the source, okay, the source, sorry, not the source, the treatment plant and the the distribution system and the consumers, they are at a place that is having a different head. Okay, so you can see here that the distribution system it is at a higher head and higher elevation, you can say, or and here the this consumers, they are staying at the low lying areas. Okay, so what happens? Obviously, since the distribution system is at a higher elevation, so the water from the distribution system it can easily flow to the consumers. Okay, to the consumers by action of gravity. Okay, so this system it is known as your gravitational system. By action of gravity, the water is distributed to the consumers. But the what is the criteria? That the distribution surface distribution, the reservoirs it should be at a higher elevation, and the consumers they should be staying at a lower elevation. In that case, your the water can be distributed by your gravitational distribution system. Okay, so the next is one is your pumping system. Okay, so what is a pumping system? So in your pumping is just the reverse of your gravitational system. Okay, so you see here in this diagram you can see that the treatment plant is at a low lying area, and the consumers they are staying at a high elevation. Okay, higher elevation. So obviously if the treatment plant is at a low level surface, so it cannot, it needs something. Okay, it needs help. so that the water it can be supplied to the consumer. So with the help of what? We all know that we need a pump. Okay, we need a pump for supplying the water from a low area treatment plant to a high area consumers. Okay, so we need a treatment pump. So here in the diagram you can see this treatment plant is connected to a pump, and from the pump the water is being supplied, okay, to a by lift is developed, and then your water is supplied to the consumers that they are staying in a high level source. Okay, so that is your pumping system criteria. Then number three is your combined gravity and pumping system. So from the name itself you can make an idea that here your combined both gravity and pumping system is required. But for what when this is required? Okay, so this is required in those areas where you can say the water it is not available throughout the seasons of the year. Okay, so in those cases what it is done is that the whenever the water is available, so the water it is being stored in the this distribution system. Okay, with the help of a pump. With the help of a pump, so what it is done that the water it is collected from the source, collected, and then it is stored in the distribution system, and from that distribution system it is being supplied to the consumers. Okay, so and the consumers are they are staying at the low level area. Okay, so in that case your both gravity and pumping systems are being used. Okay, so this is all about your distribution system. So everything you need to note it down in your copy. Okay, everything like this only the important things only I have given. So first of all, what is a distribution system? You need to note it down. From here you can write it down. Then requirements of a good distribution system also you need to note it down. Then your layouts of distribution system. Okay, this 4 points along with the diagrams and along with the advantages and disadvantages. Okay, if someone asks you the advantages and disadvantages of your this suppose ring system, okay, then you can write the advantages and disadvantages of the grid iron system since it is same. Okay, so these diagrams are also important. Okay, since it is a layout, so in the exams, if it is if it's a physical, you need to write it in your copy. If that kind of exam happens in future, so you need to draw this diagram. Okay, diagram is important, and then you need to write it down a brief. Okay, then along with the advantages and disadvantages if it is asked to write so. Okay, then next is your methods of distribution also. The diagram is important. Okay, diagram is important, these three diagrams, and then you write down in shorts. Okay, in a brief manner you write it down in your copy. So by today I will provide you the this PDF. Okay, I will provide you this PDF. Okay, so do we have time? It's 1:37. 40 minutes. Okay, I think after 5 6 minutes the meeting will end. So let me take the attendance first. Okay, and if time is left, then I will take the next one. Okay, so with this distribution system, we have completed our module one. Okay, module one we have finished about your raw water engineering. So from the next class, we will be dealing with your this module two, that is about your sewage system. Okay, so this if I complete this sewage system anyhow, if I can complete the sewage system, then now number 3 4 and 5 module that is about pollution and all, I won't be going in much details because pollution I think everyone knows about this pollutions and all. So within 3 4 classes I can finish the this number 3 4 and 5 module. Okay, I need 3 classes for that. or 1 week, you can say within 1 week I can complete those three. Okay, but the major and the vast syllabus is all about your the first module and second module. So first module I have completed today. Then from Friday I have two classes. I will be completing your I will be starting your sewage part. Okay, I will try to finish as soon as I can. So today's date is 7. Okay, roll number 1.
Ma'am.
Okay, 2.
Yes, ma'am.
Okay, 3,
Present, ma'am.
4, 5.
Present, ma'am.
Roll number 4 is present.
Yes, ma'am.
Okay, 5, 6, 7. Roll number 7. 7 is not present. 7 is not present. 8.
Yes, ma'am.
Okay, 9,
Present, ma'am.
10, 11, 11, 12.
Present, ma'am.
Okay, 13,
Yes, ma'am.
14, 15, 16, 17, 18. Roll number 18. Long Kumar. Okay, 19,
Yes, ma'am.
20.
Present, ma'am.
Okay, 21. 21 is present.
Ma'am.
I can't hear you. If you are present, 21, please mention in the chat box. Okay, 22.
Yes, ma'am.
Okay, 23.
Yes, ma'am.
Okay, 24.
Yes, ma'am.
Okay, 21 is present. Okay. Then, okay, 23 I have given present. 24
Ma'am.
present. Okay. 25,
Present, ma'am.
26.
Present, ma'am.
Okay. 28, 28. Chris, roll number 11 is present. Okay. Then 28, 29. Okay, to 30.
Present, ma'am.
Okay. 32, 32, 33, 34, 35, 36, 37, 38, 39, 40.
Present, ma'am. 39.
39 present. 40,
Yes, ma'am.
41, 41, 42, 43.
Yes, ma'am.
Okay, 44.
Yes, ma'am.
Okay, 45.
Present, ma'am.
Okay, 46.
Yes, ma'am.
Okay, 47, 48, 49, 50. Okay, just listen once. Okay, the absent ones. Roll number 5, 6, 10, 14, 15, 16, 17, 18. Then roll number 27, 28, 29, 31, 32, 33, 34.
34 present. 43. 43 present, ma'am.
Okay, 34 present. Then
Ma'am, 18 present.
18 present. Okay. Then 35, 36, 37, 38, 41, 42, 47, 48, 49, 50. Okay, these are absent.
Ma'am,
Yeah, yeah.
29 present.
39,
29.
29. Okay,
Yes,
29.
ma'am.
Okay, two. Okay, okay. Anyone else? 29, 29. Okay, 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 29. Okay Anyone else is present? 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 27. 27, but there were 29